be talking about Unit 9A today. One of the things we're going to be talking about is a function. A function is a relation that maps, this is the mapping here, of a set of numbers called the domain, which are the input values, to a set of numbers called the range, which is the output values. We usually represent that as an ordered pair, input, output. So I wrote a generic, usually this set is called big X, and this set is called big Y. The individual elements inside set big X are called little x with a subscript like 1. Little x subscript 1 is going to map to, if this function is called f of x1. You should have seen this notation somewhere in an algebra class that you took before this. Another name for f of x1 is going to be y1. There's no reason I have to call this f. We just use the letter f because it's the first letter of the word function. But we could also call it g. We could call it capital C if it's a cost function, lowercase p if it's a price function, capital P if it's a profit function. We choose letters that make sense to us based off of what we're talking about. It's part of good documentation, good communication strategy to choose names that are meaningful when you can. So I just wanted to review what the teacher means when she talks about a function here, that it's about inputs and outputs. Not always a formula for those things. Sometimes we just have points like we have here, and we are going to assume in this section that we can connect the dots and that things are going to behave the same way between the dots as if we just connected them with a straight line. All right, input values usually go on the horizontal axis on the bottom. Output values go on the vertical axis. Here, this would be our x-axis usually. This would be our y-axis usually. This input value is going to be called our independent variable. This output here is going to be called our dependent variable because y depends on the value of x. X doesn't depend on anything. We get to choose x, it's independent. Then y gets calculated based off of the x that we choose. The value of y depends on our choice for x or whatever other variables. We're going to talk about a lot of things here that depend on time. So we might use the letter T to stand for time instead of the letter x. Again, just kind of tell people what you're doing by your choice of variables. So we described this here. It was asking us about how many cars were sold in 2003. We went and we took 2003, which is this point right here. We identified it. We followed it over to the y-axis to the best of my ability. And I'm going slightly downhill here. I can't do that very well with my mouse, but try and see that I'm going to end up right over here, 550. Do my best to make that horizontal, hit that point right there. So 550 is what we said was the value at 2003, and that's going to be 550 cars, right? Units are going to be important here. Same problem, basically. Just the words instead of the picture there. All right, next problem is going to be to identify what the input values are, the domain, what the output values are, the range, and to describe the domain and range. So our independent, and what's our independent and our dependent variable? So our independent variable, our input values are going to be time measured in years. Our dependent variable is going to be the average age of death measured in years. Answer key gives slightly different answers to this. I'll tell you why I picked my answers the way that I did. So when I pick domain and range, I'm going to try and box the function in with a rectangle here. And where the minimum x value is the left-hand side, the maximum x value is the right-hand side, the minimum y value is the bottom, and the maximum y value is the top. If I can box it in like that, then this left-hand side here is the lower bound of my domain. The right-hand side is the upper bound of my domain. These are solid dots, so those are included, so I give them brackets. Same thing with my range. This is my lower bound. This is going to be my upper bound here, and I had to approximate those. I'm not actually sure that I got them exactly right, but I guessed by looking at the y-axis over here that this was 62. The teacher said 0 in the answer key. I would not agree with that because we're nowhere close to 0 anywhere here. There's no average age of death that would be a acceptable output of 0. So I think that the computer got that one. I think it goofed when it made the answer key. So it should be whatever this minimum y value is here, which is about here on the graph. That looks like that's about 60. So I guessed that that's about 62. Could be wrong. Could be closer to like 65 or something like that. But I just took my best guess based off of what I could see. This is a slightly different picture, but just about the same here. So domain and range again, roughly the same. The average age of death is a function of time. Both are measured in years. The slope right here is basically constant. It looks linear, right? And it is a positive slope, meaning that as time increases, that the average age of death is also increasing. And then this is kind of to put 4 and 5 together here, that they were asking us what's in independent and dependent variables. Our independent variable here is going to be the date or time. But I'm going to say the date. I'm going to change it to what's called a Julian date, where I number the days of the calendar year from 1 to 365. And my domain is going to be all values from 1 to 365. And my range is going to be all possible temperatures from 38 degrees Fahrenheit to 89 degrees Fahrenheit. I said that over there already, but the domain is going to be all possible Julian dates for the year. Well, that's going to be 1 to 365. So I just wanted to specify that specifically what I was saying, and I didn't get it perfect, I don't think, but if we look at number 5, we see the trend here. I got pretty close to what's going on there with the graph, and it's going to go sharply down, then sharply up, then it's kind of going to rise for a while, and then it's going to fall for a while, and it has a sharp drop off here in the fall between, you know, when the seasons change here, and it goes from summer to fall, and then it starts to fall off there. Right here, see that in October, kind of a sharp drop off here between September and November. So, and then it just kind of starts to slide down to December again. And we get down to about the same low temperature in December here that we had in February there. So end of December. So as you can see, it's not you can see trends here, but you're not going to get specific numbers. It's not like, oh, you know, every year on December 31st, I'm always going to have this particular temperature. Now, that this temperature here, even though it was only different from one day on the calendar, look how much different that was that somehow there were days with higher temperatures on January 1st than there were on December 31st. So, all right. That's it for this section. It's really not a lot. It's more conceptual than it is anything to do with calculations. And just make sure that you understand the concepts of input and output, domain and range, that you can write those in interval notation if you need to. Again, you're going to be recognizing things off of a multiple choice quiz or test. That's it for right now. See you for the next video soon.